Hello, friends. Today we will dwell into the fascinating world of AI agent architectures, the conceptual frameworks that define how machines perceive, reason, and act in their environments. These structures are the backbone of autonomous intelligence, enabling agents to interact with their surroundings and achieve goals. AI agent architecture provides a foundation for designing and implementing intelligent systems. By offering a systematic framework, it allows researchers as well as engineers to build agents with specific features and functions while enabling them to evaluate complex AI systems methodically. Now, let's explore the core components of AI agent architecture and how they contribute to an agent's capability. Yeah. So let's move on to the first component, which is profiling module, which is called the eyes and ears of the agent. The profiling module, also known as the perception module, equips an agent with sensory expertise, equips them to monitor the environment, perceive from the environment. Just as human senses gather information about the world, this model collects and interprets raw data from the environment, filtering out unnecessary details and identifying crucial features for decision making. Imagine a self-driving car equipped with radar, lidar, and cameras. The profiling module processes input and this from the sensors, identifying obstacles, traffic lights, and lane markers, ensuring the vehicle navigates safely and effectively. So on the screen, you are seeing the diagram of autonomous vehicle, and you can see the various components which are there on this autonomous vehicle: cameras, lidar units, stereo cameras, global navigational satellite system, radar, computer. Okay. Now let's move on to the next module, which is the memory module, which is also called a repository of knowledge. The memory module serves as the agent's knowledge base, much like our short-term and long-term memory. It organizes and stores data, rules, patterns, and past events, enabling the agent to learn from interactions and make informed decisions. Consider a virtual assistant, a chatbot. Its memory module helps it recall customer preferences, product details, and frequently asks questions, ensuring timely and accurate responses during the conversation. So here it is like it perceives, then it goes into memory stream, then retrieval, then retrieve the memory to plan, to reflect, then again update the memory system, and from retrieved memories it goes to the output, which is the action. Yeah. So let's go to the third component, which is planning module. So what is planning module? It's also called the strategist behind decisions. So the planning module is the agent's central decision-making hub. It analyzes the current situation, considers input from the memory and profiling modules, and devises strategies to achieve goals. Techniques like optimization algorithms or rule-based systems are often employed to determine the best course of action. For instance, a delivery routing agent uses its planning module to optimize the routes and schedules, factoring into the traffic, delivery priorities, and vehicle capabilities as well. So let's move on to the fourth aspect, which is the action module, from plans to execution. Yeah. The action module transforms the agent's plans into the real world actions, which is the expected thing. Working with actuators or output devices, it executes a selected course of action while providing feedback for adjustments. In a manufacturing setting, a robotic arm receives precise commands from the action module to assemble parts. By controlling the arm's movements, it ensures accuracy and efficiency in production tasks. And finally, the thing is the learning strategies. So we have roughly three strategies which is listed there. Okay. So the first one is supervised learning, which relies on the labeled examples to predict the outcomes. Then we have unsupervised learning, which discovers the patterns in the data without the guidance or the labeled data. Then we have reinforcement learning, uses rewards and penalties to refine the behavior. Now, these strategies enhance an agent's ability to learn from experience and adapt to new challenges improving the performance over the time. So AI agent architecture are essential frameworks for understanding how intelligent systems perceive, reason, and act independently. The components we have discussed, like profiling, memory, planning, action, and learning, work in harmony to enable agents to interact with their environments and make decisions and adapt when necessary. By integrating sensor capabilities, knowledge storage, strategic decision making, actionable execution, and adaptive learning, these architectures pave the way for creating agents capable of performing complex tasks. As we continue to innovate, AI agent architectures will remain at the heart of the advancements, driving autonomous systems like autonomous cars towards the higher level of intelligence and capabilities. Hope you like this presentation. Thank you.